Welcome students. Myself Dr. Monika Khetarpal. I am Associate Professor of Physics in Government Dungar College, Bikaner. I welcome you all in the lecture series of my virtual lab. In our virtual lab, we will perform experiments which are based on operational amplifier. For this purpose, students, you have to download LTSpice. It is a free version, so you can use it easily. But before performing an experiment, it is preferred to know its theoretical aspects. So in our today's lecture, I am going to discuss about op-amp, that is how to use an op-amp as inverting and non-inverting amplifier. What is operational amplifier? Operational amplifier is an integrated circuit. It amplifies weak electrical signals. This operational amplifier is a voltage controlled voltage source which has a very high gain. This is the symbol for op-amp. In short form, we write it as OP-AMP. It consists of two input pins. These are the two input pins and there is one output pin. The major role of operational amplifier is to amplify the input signal and output the voltage difference between these two input pins. Now we'll discuss the various terminals of this operational amplifier. The operational amplifier consists of two input terminals. This is the first input terminal. This first input terminal is known as inverting input terminal. It is marked with a negative sign. The another input terminal which is marked with a positive sign, it is termed as non-inverting input terminal. The difference between these two input terminals is that when the input is given on minus sign, that means on an inverting terminal, then the output signal is 180 degree out of phase with input signal. But when the input is given on non-inverting port, that means on the plus terminal, then the output signal is in phase with the input signal. Here VCC and VEE, these are the two power supply that are needed in the operational amplifier. VCC is a positive power supply port and the another supply, that is VEE, is a negative power supply port. Since there are two input ports, inverting and non-inverting, we have a two input voltages which are denoted by VP and VN. And the output port, this is the output port. Here we get the output voltage which is denoted by V0. The input voltage Vi will be the difference between the voltage of two input ports. That means Vi will be Vp minus Vn. Now, in order to use an operational amplifier, we give it a feedback. Generally, the feedback that is given is a negative feedback. So, we will discuss about negative feedback. Most of the basic operational amplifier building blocks, they rely on negative feedback. For a negative feedback, this output is connected to a inverting terminal. Here we have shown a feedback path where the inverting terminal is connected to the output terminal via path which is termed as feedback path. Here we have not shown the biasing voltages, that is VCC and VE, for our simplicity, but they are in the circuit. Now we can build our inverting amplifier as well as non-inverting amplifier using this negative feedback. Here I have shown an inverting amplifier which is having a negative feedback. This shows the inverting terminal of operational amplifier. A feedback resistance is shown by R2. It connects output voltage to a inverting terminal, that means negative terminal. Now, if we apply our input to non-inverting terminal, then this is a negative feedback amplifier of a non-inverting amplifier. Now we'll discuss these two type of amplifiers, that means inverting amplifier and non-inverting amplifier. This is the basic circuit of inverting operational amplifier. Here we have a feedback resistance RF and this is the input resistance RIN. Since we are giving input on an inverting terminal, our input is denoted by VIN and we get an output which is shown by V out. In this inverting amplifier, the gain is AV, which is V output upon V in. It is equal to minus RF upon RN. Here we can see that this gain has a negative sign. This negative sign indicates that in the output, the polarity of output is opposite to the polarity of input. I am showing this by taking an example. Here we have shown an input wave which is a sinusoidal wave of phase 0 degree. And when this type of wave having an amplitude, here I am showing the amplitude 5, it is applied to an op-amp, we get an output wave which is also a sinusoidal wave, but there is a phase shift of 180 degree. And the amplitude of it is magnified with a factor of 2. In this graph, this is in the red line shows our input curve and the blue line shows our output curve. We can clearly see that input and output have a phase shift of 180 degree. Along with this, we can also see that our output wave is amplified as compared to the input wave. This operational amplifier has some ideal conditions. The ideal operational amplifier rules are that input voltage must be 0. That means on the two ports, the voltage was Vn and Vp. These two voltages must be equal. The second condition that is important for an ideal operational amplifier is that in the input terminals, there must be zero current. This condition corresponds to the condition that input resistance of op-amp must be infinite. The output resistance of op-amp is 0 and the open loop gain for an operational amplifier in an ideal condition must be infinite. Now I am going to discuss the operational amplifier when input is applied on a non-inverting port. That means we are discussing non-inverting amplifier. So in this condition, a change is that we have to apply an input on plus terminal. That means non-inverting terminal. This is our input resistance. This is the feedback resistance. In the case of non-inverting amplifier, the gain factor comes out to be V out upon V in. It is the ratio of output voltage to the input voltage. This gain is equal to 1 plus Rf divided by Rn. Here the gain is positive. This positive sign means that phase of input and output are same. And in this graph, I have shown the input signal as well as output waveform of a non-inverting amplifier. Here we are using sinusoidal wave. This is my input wave and this is the output waveform. We can clearly see that on using op-amp as a non-inverting amplifier, our output has been amplified and this output signal is in phase with the input signal. So we can say that our non-inverting amplifier, it acts as a voltage follower circuit. So we have discussed the use of operational amplifier as inverting and non-inverting amplifier. This operational amplifier has a numerous applications. Operational amplifier, they are used as building block in many electronic circuit. And these operational amplifiers can be used in different type of amplifiers like inverting, non-inverting, differential, summing. Along with this, operational amplifier can perform many mathematical operations such as addition, subtraction, multiplication, division, and many more such as differential and even integration. Op-amps, they are used for the construction of filters, providing high pass, low pass, band reject and delay functions. Operational amplifier has a great advantage. It can be used as a comparator. We can compare the small difference between the input voltage by using an operational amplifier. We can construct our Wien bridge oscillator using operational amplifier. Along with this, operational amplifier can be used in nonlinear circuits such as logarithmic and anti-logarithmic amplifier. Operational amplifiers have also a large number of applications. They can be also used in signal processing circuits such as clamping circuits, precision rectifiers, and sample and hold circuits. These op-amps can also be used as voltage sources, current source, and current sink, and even they can also be used in DC and AC voltmeters. So students, this is the basic theory of operational amplifier. In our next lecture, we will discuss in our virtual lab the experiment that will be performed on op-amp, in which op-amp will be used as inverting and non-inverting amplifier. For this purpose, we will be using LT-Spice. So students, you are advised to download the LT-Spice, which is a freely available software. Thank you for watching.